we're looking here at Clover Basin, standing on Clover Hill, and what we're seeing in front of us is really a remarkable panorama of geologic history. So in a different video, we'll talk about the high-grade gneisses that make up the top of the range. You can see Chimney Rock up standing prominently away from the range. That's made entirely of Chimney Rock orthogneiss, 2,450 million year old deformed granitic rock. So those are the oldest rocks in Nevada. And between us and that is a remarkable system of faults and sedimentary rocks. And it's not as spectacularly exposed as the high country, but it's just as spectacular in terms of the geologic story that it tells once you have the patience to work through it. So most of the foreground, I should say, was mapped by Art Snoke, who will appear in a different video. And what you have in the grassy slopes, the forerange, the foothills, if you like, of the East Humboldt Range, is a series of Paleozoic rocks ranging from Mississippian up to Permian. So that's the upper half of the Paleozoic. And each of those is tilted and sliced and separated from the next one by a normal fault. So we're seeing a series of faults that drop down everything in the foreground toward us here. And indeed, we, standing here on Clover Hill, have been dropped down relative to the high-grade gneisses up at Angel Lake. And so the rocks we're standing on right here could have been restored back up into the air and would line up more or less with Gray's Peak at the highest levels. As it dropped down, the rocks that were sitting on top of that were preserved. And so on top of those, the faults that are responsible for dropping that down, the youngest one is essentially at the foot of the mountains. And there's a couple ways, even from here, that you can recognize that fault, called a range front fault. And pretty much all the mountain ranges, the big mountain ranges in between Reno and Salt Lake City, in this province we call the Basin and Range, pretty much all of them are lined and were created by this kind of fault. One way you can recognize them is that there's lines of green where these faults, the broken up rock, feeds water up. And that will tend to produce a vegetation lineament. And so where you see the green kind of spreading out at the base of the mountains is especially conspicuous over here. That's right along the fault. And if you go along, we have one of these on the west side of the range as well. And you can almost pick out the fault by looking at where the ranch houses are, because they've sited where they could get water. So these vegetation lineaments that we see at the foot of the mountain ranges bring water close to the surface. And in fact, you can almost map the faults where there are farms or ranches, because oftentimes the ranch houses will be right at the foot of the mountain range, right along the vegetation lineament, because that's where they can get water. That's where the water is brought closer to the surface. Another, at deeper levels, that water can also transport mineralizing fluids. And so if you're imagining as the rock is being carried up, fractured, the water is moving through it, it's precipitating, will precipitate silica and make a rock type we call jasperoid. And if it's very pure silica, it would make the gemstone we call jasper. That is, we can see that in the range front as a wedge of jasperoid breccia, fault breccia, right along the range front. The next thing we see out from that, we begin begin seeing our sedimentary sequence. And the base of that, the oldest rocks, we have found some volcanic tuffs that date as old as 28 million years. In fact, there are some older ones that date as old as 40 million years, some volcanic andesites. And from that, there's a fairly thin sequence of sediments from the 40 million year old sediments to about 28 million years. And then most of the foreground right here consists of layers of rock that are actually dipping toward us. They're slanting toward us, although that's difficult to see because of the vegetation that's grown over it. But Art, through several summers of patiently going out, finding bedrock outcrop, was able to reconstruct a really fascinating story of that sequence of rocks, which we now know dates between about 22 million years, at least the upper half of it dates between about 22 million years and 17 million years. Again, based on dating some volcanic tuffs that fell into the basin. Most of the rock, however, is of two types. It's either lacustrine sediment, so lake deposits, and some of that has fossils in it, or it is conglomerates. And so these conglomerates are the first sign we get that we had a steep range front that was eroding and producing, shedding high energy rocks down into the depositional basin. The other evidence we have is some bold outcrops that you see. The largest outcrops you see out here have been interpreted as megabreccia deposits. Now this isn't fault breccia. It's a breccia, broken up rock from gargantuan ancient landslides or rock avalanches down into this lake basin. And so some of these can be hundreds of meters long and 20 meters thick. And they are, so they're another sign that you're beginning to see development of a very steep landscape more similar to what we have today. Again, that dates to about 20 million years ago. Starting about 17 million years ago, toward the red hills that we see, the jagged red hills in the background, the base of those are underlain by a formation known as the Humboldt Formation. And this is the main formation that underlies the valley west of the west of the Ruby Mountains and the East Humboldt Range. And it consists, again, of some lacustrine deposits, some conglomerates, a lot of volcanic input, a lot of volcanic tuffs, and even volcanic rhyolites, such as the rhyolites that make the red hills. And here we see it tilted and at its very thickest, up to 5 kilometers thick. So it extends all the way from Clover Basin here, all the way to the west side of the town of Wells. And so you see a really exceptional section through this, although unfortunately it's not very well preserved.